Hi everyone, we continue descriptive statistics for Georgia voting data. So last time that we discussed histogram, so this time we start with the categorical data. So suppose we want to summarize the GA vote equipment data. So G and GA vote are the same data frame. So GA equipment is this one. So we have 5 levels. Maybe we can see first 20 observations by this. And we have 5 methods: lever and optical system with central count, optical system with precinct count, and paper and punch. To summarize this, you can type the table of G $ equipment, then we can make a table. But to make a graph, usually we want to have this in decreasing order. So we sort this decreasing T. Then you can have these 5 categories by decreasing order of counts. Then we can make bar chart, bar plot of this. Then you can make this bar plot. If you want to change the direction of label, LAS option equals to 2 makes this. Next, we want to discuss how to see the relationship between the 2 numeric variables. So at first, we want to define the percentage voted for Gore. So that is the G $ Gore divided by G $ votes. So this should be percentage, so it's around 50%. That should be Gore, so first 10 observations, about 50%, maybe sometimes much larger than 50%, sometimes much smaller. Okay, we want to see the relationship between this variable and the percentage of African American. Then you can use the plot function, percentage Gore and percentage African American. Percentage African American has been in the dataset at the beginning. So we are using the data frame G, so you can type in this way. Then you can see this graph. So you can see we have very strong relationship between the percentage of African American and percentage of Gore. So more people, more percentage of African American, higher percentage of African American, then the percentage who voted for Gore is higher in 2000. Next, we want to discuss the 2 categorical variables. Sometimes we have 2 categorical variables and those 2 are related. So one example is variable Atlanta and the variable rural. So rural is either rural or urban. Atlanta is either Atlanta or not in Atlanta. So you can imagine that most counties in Atlanta city are urban. So these 2 variables are related. And if you type X tab tilde this, then you can see this so-called contingency table for rural and Atlanta. And most cities in Atlanta city are urban, 14 out of 15. But not in Atlanta, counties not in Atlanta, most counties are rural. Okay, so here it's a little bit confusing that the variable's name is rural, but the possible values are also either rural or urban. So we want to assign different name for this variable. And how to do that? You can use the name of this G. Names. Then you can see all names of the variables in data frame G. And we want to change this name. So fourth element of names. So names G 4. And we want to change it into usage. So I follow the textbook. I don't know why that this is usage. Maybe usage of the variable name isn't really appropriate. Okay, so now we want to compare the continuous variable and categorical variable. For example, we want to see if undercount percentage is different among different counting system. That is common, natural question. So we want to see those, and to see that information, that you can type plot by equipment. Actually, this is the same code as before, so two continuous variables. But if one variable is categorical, it makes the so-called box plot. And we can see that actually the equipment type doesn't matter for undercount. Maybe slight difference, but all 5 methods have about 4% undercount, and we don't have any significant tendency between these. We have some outliers for these two. But overall, these 5 different methods that don't affect the percentage of undercount. Okay, so finally, we want to see many continuous variables at once. So see this. Okay, so maybe we see the data again. We have several continuous variables: percentage of African American, and also undercount percentage, and the percentage voted for Gore. Actually, I made a mistake, so we have 2, but the percentage of Gore, and maybe that we also try to analyze ballots. So this is the 3rd column. Percentage of African American is 3rd column, and we have 3, 6, 9, 10. So ballots is 11th column, and undercount the 12th, and this is 14th. 1, 2, 3. Yes, 3 and 9. 10, okay, 11 and 13, 10, 11, 13. So we want to summarize the information of 3rd variable, 10th variable, 11th variable, and 13th variable. So we name this as maybe name of index 3, 10, 11, 13. Then if we type the correlation, this data frame, and pick up these 4 columns, you can see correlation between these variables. We have seen that percentage of African American and percentage voted for Gore have very close relationship, and actually correlation coefficient is 0.92. It's very high. And others are low, but still we have some positive association between undercount and percentage of African American, and undercount and percentage for Gore. So maybe the people who voted for Gore claims that it's not fair because when we have more votes for Gore, we have more undercounts. So in total, maybe Gore has more undercounts. And okay, so this is not really fancy to see. And actually, if we have many numbers, it's hard to see which is largest and so on. So if we use library correlation plot, CORR plot. You can visualize this. So you can see this. So this so this is a kind of heat map. So the blue, the deep blue is 1, and 0 is white, and the deep red is -1. So we see this has positive correlation. Of course, this is the same variables, so correlation is 1, but the percentage of African American and percentage for war are very have high correlation, so almost the same size as this one. And color is also similar, slightly lighter here. And this and this are blue, but almost pale blue, so its association is weaker. And actually this is negative. So if we have many variables, then it's useful to use this kind of graphical information. Also, if you want to see multiple scatter plot at the same time, you can type pairs, G, NIX, then you can see all pairwise plots. So this has duplicated information because this scatter plot and this scatter plot are essentially the same. Both just the relationship between percentage AA and the ballots. So, but just this y-axis and x-axis are interchanged. So you can see positive association here. Slightly positive, maybe others are not really clear. Okay, so this is the end of the first part, the descriptive statistics in R.